Well, hello, and good morning, everyone. Or good evening, or good night, or good whatever, depending on where in the world you are. For me, it is morning. This is probably the earliest stream I've ever done. So let's see how this goes. If my brain works this morning. And we seem to have some people in the stream, so that's nice. Welcome everyone. So I've been doing quite a lot of streaming this week, actually. Been getting some pretty good work done. And 2 days ago, I was working on the intro sequence for the Traction Point demo. And ran into some streaming issues. Not streaming issues as in live stream, but actually streaming issues as in streaming data in the game engine. And I had to figure those out before continuing. Hey, Happy Strat. Good night from Brazil. Well, good night to you. Hope you have a good night and evening over there. Yeah, we had some streaming issues last time, preventing basically this script from working that I created, which I have since fixed. So I had a look yesterday at the engine side, figured out some streaming issues. Actually, I managed to get quite a few bugs fixed that we had problems with earlier in the week in the streams. Those of you who were around might remember that I had this empty power cell here that I needed to put on like a different layer in order for it to actually get properly put into this receptacle here. Otherwise we just got an error. So that's now fixed. It can just live here right next to these other things. This full power cell and the empty one, they can be loaded the same way, even though one is inserted into the receptacle directly and the other one isn't. And I was also able to get rid of this horrible timer hack that I had to put in here. Actually starting the mission. See what the thing now looks like if we actually play the game. So last time we put in like a small sort of, if I start the mission here now, you can see that the camera animation plays. You can see the two cars arriving from over there. We're kind of supposed to be this guy here. A few problems with this. First of all, we don't have camera blending working, which is why the camera sort of just hangs back and actually intersects with this mother vehicle. It's supposed to sort of catch up to this guy and sort of smoothly blend into gameplay camera. You can see that it kind of just jumps to this guy when the sequence is done. The other problem is that you can sort of hear me trying to drive with this guy. It actually can't do that. And the reason is that the AI needs a little bit of tweaking. Namely, it has sort of arrived at its destination, but the AI is still conceptually driving this thing. It's just like driving in the sense that it's standing still. So it's applying brakes, and we can't do anything about that currently. So we need to sort of add a function to the AI so that like when you're done with the thing that we ordered you to do, just, you know, stop controlling the car so that the player can take over. And the vehicle is here, so scout. We send this mission intro move to the vehicle, sets the brain to active, and then it moves to the target, scout intro target, which should be right about here. So it drives to this object here, along this road, and then it, when it gets to this object, it sort of starts to drive. So it starts to drive, and then it stops. So it drives to this object here, along this road, and then it, when it gets to this object, it sort of starts to drive. So it starts to drive, and then it stops. So it drives to this object here, along this road, and then it, when it gets to this object, it sort of starts to drive. So it drives to this object here, along this road, and then it, when it gets to this object, it sort of starts to drive. So it drives to this object here, along this road, and then it, when it gets to this object, it sort of starts to drive. So it drives to this object here, along this road, and then it, when it gets to this object, it sort of starts to drive. So it drives to this object here, along this road, and then it, when it gets to this object, it sort of starts to drive. So it drives to this object here, along this road, and then it, when it gets to this object, it sort of starts to drive. So it drives to this object here, along this road, and then it, when it gets to this object, it sort of starts to drive. So it drives to this object here, along this arrives here. But the AI is still sort of controlling the car. That's why we can't drive it. That's a problem. So we're gonna have to probably start with that actually, and make it so that we can tell the system to like drive here and then you know, let go, relinquish control of the car. And we can see here in move action.zig. So this is the action that we use to actually have it drive somewhere. This is put into the action scheduler. So this has like a start and a stop. It can update itself. Not that it really actually does anything currently here. But it returns its state, so the system knows when this action is done. And we just need another action which is like almost like instantaneous. It won't have like a start and an end. It would just be like, let go of the controls, please. Disable yourself. This is a pretty interesting, this is a pretty simple action actually, because most of the really heavy lifting is handled inside the AI driving component. So this basically just, when this action starts, it tells the AI driving component to move to the position. And then it has a callback when that thing is done. Callback is down here. This is where we actually, I had a hack here to actually make that, make it actually deactivate the driving component. This did work, but it actually broke the other vehicle then, because then it's always deactivating the driving component when it's done, and that's not necessarily the case. We need to specifically tell it to like, here, you're done, give control back to the player now, please. So let's get rid of that stuff. So now we can just see that when the movement finishes, if it is successful, then we just set the action state to succeeded. Otherwise to interrupted. And that means that the AI system knows that this action is done. We can continue with the next one if we have a next one. I hope that makes sense. So let's start by actually adding one of these actions here. Did I have any notes for what that was supposed to be called? Release AI driving action. Maybe it should be sort of like release AI completely or something like that, right? Disable AI. Disable AI action. Does that make sense? If you have an object that is controlled by AI and then at some point you just want it to not be controlled by AI anymore, then kind of makes sense to have an disable AI action. So let's go with that and let's see where that takes us. So disable AI action .zig. Right. And what am I doing here? That's not what I wanted to do. I wanted to resize this thing. So let's put disable AI action here on the side. And I will actually copy paste this guy because we need to adhere to the action interface. So this would be disable AI action. This should be actually very, very simple, right? Don't need it vector trees. We probably need actor contexts. Stop reason. What is this? Finished interrupted. Maybe we need that. Maybe we need that. Right, so we can take all of that away. Driving component. We may or may not have a driving component for something that wants to disable the AI. That's not super important. Can get rid of the set params because there probably won't be any parameters to set here. Vehicle helper library. Yeah, might actually need that. Let's see. Where's AI driving component? Right, this is right here. Yeah, this is a pretty big component, as you can see, like almost 700 lines currently. This has some API that we can use. Let's see. There's a tick one. There's a driving API. So deactivate. This is probably what we want to have happen, at least. But we might actually want to disable more than just the driving, right? If we have some other AI systems running on the agent, we probably want to disable kind of like all of them. So actually, maybe we will want to have like a set params method like this, right? Where we can sort of specify what we actually want to disable. But for now, let's just keep it as simple as we can. Yeah, it's been actually quite some time since I worked with the AI before this week. I think it was like half a year ago or something that I wrote this system, so I have to sort of remind myself of how this works. All the AI actors have an actor context, which has the game object pointer and an optional driving AI component. And then the idea here is that when we have more of them, we can add them here later. But yeah, we don't really have anything other than the driving here currently in the AI context. So basically, when this event just do all of its business here in the start method. It doesn't really need a stop or an update. We still need to have them here because that's kind of how the AI system is supposed to work. Yeah. Maybe we'll actually put them here and have it just run one single update and then stop. And that's kind of how these things typically work. So let's see, we have the action interface. This specifies what we actually what we need to implement to have the AI system sort of communicating with this guy. And it looks like we have to implement all of this, even though we don't use them. So that's why we have this stupid like debug draw self, get type self. It's actually, I don't think this is used for anything yet. Yeah, that's a little stupid. I can also get rid of some of these commented out things here. Whoop, not that one. Right, so you can have these prints here. They can be kind of handy. Since we don't have any arguments, we can just make it a print. Same thing here, probably. Like that. Stop doesn't really need to do anything, right? It's just sort of, it's never gonna be stopped, I think. Yeah, I'll just actually, I think after the single update, the action state will be set to succeed, and this will never fail. It's kind of a silly action in that sense. And let's actually move this into update here, and we can just call it running disable AI action. Like this. And so this has self actor context AI driving component. So we can check if we have one of these guys. Driving comp. Then we want to deactivate that one. That is the important part here. Essentially all of the business that this actually does. Move to action without a driving component. That's, yeah, we don't necessarily need to have a driving component. It's kind of like, if we have one, then let's disable it. If we don't have one, then it's fine. It's completely fine. All right. This is sort of like the simplest action you can imagine in this whole AI system. All right. I think that should be it. Let's see if this works. And the way we do this now is in the AI brain component. We have these script functions that we can call. Move to object, for example, is the one that we use to actually order it to move somewhere. And what move to an object actually does is that it has the action scheduler and it appends an action to it with a certain layer. And the layer in the AI system is sort of like you can have multiple layers, and you can have an agent doing multiple things simultaneously. Like, for example, if this was if we had combat in this game, like one vehicle could drive somewhere and like simultaneously shoot another vehicle or something like that. And those two things would be happening on different layers then. Each layer is essentially like a queue of actions to perform. So in this case, since we want the vehicle to have like a rolling start when the player takes over, if we run this game now, I can actually just click load game, and it should trigger this thing automatically. So this vehicle is driving here towards that target. When it reaches the target, it will actually brake, come to a halt. Before that happens, like right around this point, this is where we want to actually cancel that move and disable the AI, right? So that we can then, as it is still rolling, we can start controlling the car. And that should look pretty nice. Pretty cool intro to this mission. So we actually want to cancel this move to target or move to position. What was it? What was it called? Move to object before it finishes, right? We can do that with clear layer, I think. Clears the given layer, stopping any active action. So we want to clear it, and then we want to run this disable AI. And if I'm not mistaken, then that should make it essentially keep rolling. Like the vehicle should keep moving. Let's see, if we stop this thing, driving component is active, then driving component will stop. This might be a problem actually, because this method will get called when we clear the layer. So we have the stop function here, and we call stop on it. And I have a feeling that it will actually cause the vehicle to come to a halt. Right, so we actually probably need to test that. But if we stop this action and then immediately after that we disable the AI, then the physics won't actually probably have any. They won't have maybe time to come into effect. I'm not actually sure. We'll have to look at that. Another thing that we could do is we could add here as a set params, like a break when stopped or something like that, like a parameter to tell the system that like move somewhere, but if you are stopped, then should you actually start braking, or should you just deactivate the driving? Yeah. Let's put a breakpoint here and see actually what happens, how it reaches that point. So it's essentially right here where these two terrains meet, the one that is decorated and the one that isn't yet. Okay, actually it's not stopped. Yeah, it's just finished. It's not actually stopped. So this thing never actually get called if it just naturally finishes. Okay. That's cool. However, if we now change it slightly so that we actually stop it prematurely. Let's see how to do that actually. So we have an intro timeline here. The intro timeline has some events that happen at various points in time. We have avatar set time happening 20 seconds after we actually kick off this whole movement. And when this happens, we call set avatar, right? Okay. So when this happens, we can also do the clear layer. We need the layer number. I don't remember what that actually is. Is that like 0 for the primary probably? Yeah, primary is 0. We're only using one layer now. Let's clear the layer. That should call it. That should cause it to call stop, if I'm remembering this correctly. You can see the next thing that we do is actually set the single player avatar. So that's basically like make us control that car. So let's see what happens now. So now it should stop like actually way before it reaches that, and this vehicle will probably just run into it. That's what I'm guessing will happen. Let's see. Yeah, so now it stopped there. Okay. The camera animation is still running. You can see, yeah, we get sort of overrun here by that guy. Okay. So we still can't actually control the car. That's kind of what I was expecting. Why Zig for scripting? Zig is not for scripting. This is for scripting. This is AngelScript. It's the scripting language. The game is written in Zig essentially. The tech is written in C++ mostly, but the game is written in Zig. And if you're asking why, then basically I like Zig as a gameplay language. It's very nice for that kind of stuff. So if we actually export this, now that we have this clear layer 0 here, and we can unload this backend here so that we can actually compile this guy. Now if we put a breakpoint here, now I'm assuming this breakpoint will be hit, and that will be because of that clear layer call. That's what I'm assuming. Let's see if that actually comes to pass. And actually, let's have a free camera here for a while, and let's see. So, okay, now we get that. Hey, Michal, welcome back. Now we get this. We're stopping this as expected. The state is interrupted. Yeah, that's also kind of expected. I do wonder, however, let's actually do this one more time, and let's do it without this, because I want to basically see. I'm just gonna have free camera here for a while. Is the vehicle actually braking when we call that stop, or is it just like not applying any input to the vehicle anymore? Yeah, it kind of looks like it's probably actually braking. Yeah, it's clearly actually braking. Yeah. Okay, so that's a problem. That's going to be a problem for us here. We basically don't want this to be stop. We just want it to be deactivate. When we decide that the AI should no longer be driving. Okay. That's fine. We can put in a deactivate function here. So if we are already in the inactive state, or if we are in the stopped state, we don't do anything. Otherwise we call event stopped, or event stop. Can be applied in the following drive line or reverse turn states, and it puts it in stopped. And here we can just do deactivate instead, and it will put it in the inactive state. I think this is what we actually want. This is kind of like, don't do anything, don't apply brakes, don't try to steer, don't accelerate, don't do anything. If you're wondering what this is, by the way, this is Zig FSM. It's like a state machine library. Look it up on GitHub if you're interested in using this yourselves. So let's do stop and just copy this guy. Deactivate. If we're already in the inactive state, we don't need to do anything. Oh, do we have actually redeclaration of deactivate? Ah, so we have a deactivate function already. Yeah, it's the exact same thing that we have currently. Okay, but no, then we don't need to do that at all. I'm just gonna undo everything here. Yeah, so we can just call that instead. And if we go here to this and instead call deactivate here, this should basically do the same, but it should stop in a slightly... Oh, I need to actually build this. It should stop in a slightly different way. Oh. Does it actually return something? No, it doesn't. But it's an error throwing function. Okay, well... no, that's not how we do it. Catch. My brain hasn't quite woken up today yet. So fatal error with probably name, something like this. Error. All right, and now now it should just continue rolling. Should not brake when it actually stops. And then we need to somehow make sure that that is what we're going to do when. All right, so now you can see that. Yeah, the the car just keeps rolling, and actually we can now drive it. Yay, that's cool. So of course this is now sort of a hack. We can't actually use this because in many cases when you want a move to action, or when a move to action is to come to a halt, you actually want it to stop. You don't want it to be deactivated completely. So we need to either do this or the stop one, and I'm thinking about here how should I actually make that happen. We'll probably just add a boolean here, right? So deactivate driving AI on arrival, or on stopping. Yeah, see, because the thing is here that if we are succeeding, so if we actually arrive at the target, then we don't really do anything. But here, if we have this boolean set to true, then we probably want to do that as well. So let's try something here. I just need to try this. I'm not exactly sure how I want this to work yet. But, so that can be a bool. We can format them vertically, and then just set that. Deactivate driving AI on, should be on arrival. Or deactivate driving AI after the thing has been completed. It's a very long name. What should we call this? Deactivate driving AI afterwards. Because it's like, it's either gonna, if we call stop, then it will either stop, or if this is true, then we actually deactivate it. Here we don't do anything if it is false, but if the thing has, if the movement callback either succeeds or is interrupted, then if this is set to true, again we want to deactivate the driving. Happy Strat says, I'm building my renderer in Rust with WGPU, but I haven't stopped to think about which language I could use for scripting. In the distant future, though, of course. Yeah. I wouldn't consider Zig a scripting language. Let's be clear about that. I guess you can use it as a scripting language if you want to, but that's probably not where its strengths lie. But yeah, there are dedicated scripting languages that might give you more features that you want in a scripting language. Well, yeah, sounds good. Sounds good. Something like this. Deactivate driving AI post movement, right? Is that clear enough? I think it is. So here, if self, oh, that's not like that, and we actually want this guy. Driving component, right? Yeah, we need to kind of do the whole thing. I'll just wrap that in a function because it's So what do we call this? Like on post movement self. That can probably actually be a const pointer void. Just take all of this stuff here, put it in here, and this would be like explicit stop, something like that. So if it is an explicit stop, and if it is an explicit stop, and well, first of all, I'm wondering how I should order these if statements here. If we are active, then we need to do something, right? If we're not active, we don't need to do anything at all. Here we can just call self post movement, and explicit stop is false, because this is not an explicit stop. It's like a movement callback from the driving system that, hey, I'm no longer moving. Here, on the other hand, we have explicit stop true. Like that. Right, so if we are explicitly stopping, then driving component can just be, you can just call it stop. Else we have this thing. Does that cover all the cases? I think it probably does. Except actually if we are explicitly stopping, right, we actually need to check that if self deactivate driving post movement, like that, and here we actually only want that. Yeah, that is the logic actually. And now we have some duplication there. Maybe we can get rid of the duplication. But that is actually the logic. If we are explicitly stopping, if we have this deactivate post movement, we're gonna deactivate, otherwise stop. If it's not an explicit stop, we only want to deactivate if we have this thing going. Yeah. Yeah. Wonder why I don't get this explanation for this parameter here with this post movement explicit stop thing. But oh well. It is what it is. And now we don't have, we don't actually pass that parameter here, so we need to set that here as well. So move to object. Yeah, this needs to be actually passed down from the scripting, right? Yeah, I don't really like this name for this because it's so long. I wonder if we can come up with a shorter but equally descriptive name for this thing. It needs to be passed on to the action. And then we need to also add it here to move to object. Right. Yeah, I'm not super stoked about this API, actually. Right, because the API on the scripting side works like this. If we have the scout here somewhere. There's the scout. So this thing is like, okay, activate the brain. That just basically means the opposite of like disabling. Disabling the AI that we just actually added here. So maybe we can use this set brain active. Yeah, it clears all the action schedulers layers. So what I was originally thinking would have been something like this. It would be like disable AI, right? Something like this, and then maybe it would give it like the layer ID again. And this would push one of those new disable event actions that we created to the thing. That could be interesting, because like, obviously we can't do this. Or I don't know if it's obvious, but we can't do this because it will like immediately turn the brain on, ask it to move somewhere, and if we just call set brain active false, then it will like immediately turn off the brain again, so it doesn't work. This, on the other hand, is essentially like, you know, do this and then do this. So maybe we should rename these slightly to have you know, do something like add action, something like this. I can make that a little larger. Make it clear that it's like, okay, we're adding an action to move somewhere, and then we're adding an action to disable the AI on the layer. This is Yusuf says, never knew you streamed. Nice. Yeah, I've been streaming for a couple of months, something like that maybe. Not super long. So yeah, I don't blame you if you missed it. Yeah. Right, this is like immediate, and then these are sort of just adding things onto there. But this is a pretty nice API because it's like, you know, right now activate the thing, and then you have a list of actions that it will carry out, and then when it's done it will disable itself, I guess. The layer here is actually not passed to move to object, it's just assumed currently to be on the primary layer, which is not necessarily all that nice. Yeah, it's just, I even have a comment there to like make adjustable question mark. Yeah, first of all, I think we need something like this. We need to annotate these functions that actually like push actions to the scheduler somehow like this, so that they know that this is not actually going to be carried out immediately. And how do we do that? That's a bit long. Should just be like add underscore move to object. And that's kind of the standard that we then have. or push. I think append is actually the term that the scheduler itself uses. Move to object here, it uses, yeah, so this is that's the important part. It pushes an action to the scheduler, and it's called append. There's another one that's run immediately, which just does the same thing, but it clears the layer first, and then it runs self append. So that means that that is the next thing that it will actually run. Yeah. So maybe append then is the name that we will use. Well, that didn't work. Append, move to object. Append, disable AI. Yeah. I think that's probably fine. So that kind of tells you that everything that starts with append underscore is just going to be put on the list of things for the brain to do. Let's use that. I'm gonna save that actually, but then unload that editor. I can go to the brain again and just append, move to object. Clear layer is not really an append, right? It actually just does it immediately. So that's fine. We don't need that to be appended anywhere. And maybe we actually want to reorder this, so we have all of these appendable things here, one after another. Let's move the clear layer up there. And let's move the clear layer up here. So brain active also clears all of the layers currently. Yeah. Still wonder about this. Deactivate driving AI post movement. It kind of feels like it would be nice to formalize this behavior somewhere. We have this boolean with this really long name here, which isn't very nice to work with. But maybe that is simply what we will have to work with currently. Yeah. What's this brain active do? Is this actually used for anything sensible? Or can we just get rid of that guy? Brain active bool. So it's just set there. We just return, early return here if it's not, I mean this thing is not really used for anything. Should we just remove that thing? It's just confusing. It's kind of just confusing. I'm gonna comment it out for now. It's really not useful to to anything essentially. Comment all of that stuff. And then this should probably be called append move to object as well, right? Make it very clear to everyone that that is what is happening. Like so. And that will also be append move to object. Maybe we can format that a bit nicer. So bool deactivate blah blah blah. We will need that as well here down below. And that will go into here. But that's not how a boolean looks in Zig. That is how a boolean looks in Zig. Yeah, I'm gonna break some of my levels here when I'm changing the scripting API, but that's fine. They will give me a compile error when I try to export the level, and then I will just have to go in and sort of look at that, see what is what. So that's fine. Yeah. Okay. So here we are deactivating the driving when the movement is stopped, but we still have sort of the what should I call it? The arguably some of the driving running. So I think I still want this action to be here. And then if we have some other things beside that driving that we need to disable, we can do it here. So true. If we have more systems to disable, do that here. That should be fine. And then we'll add another one of these append ones here, and we call that append disable AI. And it doesn't really need any. Does it? Should we just pass the layer there? I mean, this thing will need to be run actually on a layer, right? But then when it actually runs, it doesn't really care about the layers because there's only ever one AI driving component. Yeah, I think this actually doesn't really need to care about any layers, and neither does move to object. Move to object would always be just run on the main layer. So I think that's fine. Let's keep that as it is currently. Right, we don't have a disable AI function, so let's create one. We want this to be an int pointer. Call convention.c to be callable from AngelScript. Not exactly sure if I truly need that to be the case, but that's typically how I do it, and then we can get the actual self pointer like this. Append disable AI self void, and this can throw or return errors, shall we say, to use the Zig terminology correctly. I can't call this immediately from AngelScript because AngelScript doesn't know about the error returning mechanism of Zig. So what I typically do is I have a wrapper function which is call convention C, the same name but with an underscore prepended to it, and also it takes the self pointer as an int pointer, which is just like a usize essentially. And then I can handle the error here. If this actually gives me an error, then I need to just show it somehow. So we can do disable AI. That should be good. And this is not really how I do these things anymore. I do fatal error with name. Source giving me a nice call stack to jump to if I want to know where that is. Fatal error with format. Is that nicer? It just doesn't assert currently because that's kind of the only way to show an error message currently. Maybe this is actually the nicest thing to do. Fatal error with format. You can still pass the source there, but here we can actually have a nicer name here. So this should be append move to object, and this should be append disable AI. Yeah, that's nice. Okay. So this does a whole bunch of things. Brain active, we don't have that anymore. Just disable that guy. And this should really just be this, right? Something like that, but it's not a move to action, it's a disable. Oh, we need to actually make that available. So move to action, pubconst disable AI action is import actions disable AI action. Like so. Layer. Layer shouldn't really matter. It's an action layer primary. I'm gonna put a comment here that the layer shouldn't really matter here, since disabling the AI is a global thing. Right, we don't have like separate components for the different layers, etc. So yes, and we don't necessarily need the action, right? There's not much to configure, is there? I don't think there is. We should get this running disable AI action though when it's actually running, so that we know that okay, now it is actually doing it. Yeah, that's simpler. We don't need the brain active thingy really. I mean, I'll add it back later if I need it, but I think it's just like messier to have this boolean here, which is not necessarily in sync with the action scheduler, which is like whether or not the action scheduler has any things in it. That is really what specifies if the AI is active or not. So yeah, that should be good. See if this builds. Nope. Error is ignored. Ah, okay. Yeah, we have the same thing here as we had in the move to action, right? You need this thing. Yeah, unfortunately these interface members here can't really throw errors or return errors. since they're actually called via function pointers, or they can, I guess, if you specify all the error types that they will throw, but that's not really practical to have in like an interface. So we'll have to do it like this, just catching the error. Now then. So what was the script looking like currently? Vehicle scout. So we have that. Now if we try to build this, it will tell us that like there's no set brain active thingy anymore, and that's true. Let's get rid of that. Compiling blah blah blah. No matching signatures to append move to object. Why is there no append move to object? There should be one. Append move to object, deactivate driving. Is that the problem? Just put a boolean here to actually show what this does. Yeah, that was it. So not only do we need to actually disable the AI once this is done, but we need to disable the driving AI once this happens. The mother vehicle also has a bunch of problems now. Like, we don't need that. And disable driving AI post movement. This should be false. I think the other one should actually be true. They should be true. So that the vehicle keeps moving when disabling the AI, right? That's kind of what we want to happen. Mission intro move to object, disable AI. What we're doing currently here, though, is that we're clearing the layer. So this happens. This mission intro move message is sent to the object. We will try to drive to this object here. That will take about 30 seconds or so, maybe even longer. After 20 seconds, we get this set avatar one. So this won't actually have time to finish. And then we clear the whole layer. Right? So that's not good, because that means that this disable AI will never occur. So that's not something we want to do. Instead, we want to sort of cancel the current one. We actually have support for that in the action scheduler. Let's see. We don't have that, but we could use this run immediately. We could use this run immediately version of putting something there. Which, to be fair, is actually the same as clearing the layer and then appending it. Right? So that's what we could do. Could do here from script. We can take this away. Actually, just do this. Yeah. I do wonder though if probably wouldn't be that tricky to actually add like a cancel the current task thingy to this one. task has ended. Get rid of it. Start the next one. Yeah. Failed, succeeded, or interrupted. Then it's like removed. And then we get the next one and we start that. Yeah. Okay. Would be nice to not have to like mess around with that all that much during this stream though. Could get some cool intros going here. I mean, this will work now. It will move to the target for a little while until this set avatar message arrives. And we clear all the things and then we run this disable AI. Which like arguably doesn't really even need to be done, I guess. But this is sort of how you're supposed to disable the AI with like one of these tasks. Yeah, that will probably work. Let's try that. So now we should get the... Oh, there's some other thing that's actually not... Let's see. Blah, 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 blah. Line 6. Move to object, right? It has an append missing, right? Append is missing here as well, and we actually miss that one too. Yeah, so these were the test move to object calls that I added last stream. I think I still need to like investigate how this deactivate driving AI post movement stuff is supposed to be passed. I don't really like it that you have to pass it to each and every one of those things. But okay, starting move to action. Let's get the free camera again. And when the vehicle is, when the AI for the vehicle is disabled, we should get that running disable AI action or whatever we call it. Yes, running disable AI action. And now the vehicle is just rolling. Just a little stupid because we're just running out into the onto the grass. But now, because we don't actually disable the driving AI for the other one, if we ask it to move to the ruined house, it will actually be able to do that. Yeah, that's nice. That's nice. And it should break when it comes there. And we should see some output about that as well. Yes. Movement action finished. Movement result success. Let's have it move to the, I don't know, outside the main gate. Yep. It probably drives into the gate again. At least it did that last time. Because actually, the sort of braking distance for that is pretty big. So like, yeah, like bonk. Drives into that. Now, if we ask it to drive to the ruined house, it probably won't be able to. Like, it just tries to tries to go. Doesn't do the reverse turns yet. Ah, you're so stupid. You're so stupid. And we can switch to it, but we can't actually drive it because AI is controlling it. Yeah. That's probably something that we'll need to actually handle later. If you want to switch to another vehicle, it's driving along the road. It needs to sort of dynamically disable and enable the AI. I'm sure that's going to be a whole thing to implement. But okay. That's nice. So now at least we have the... I don't have the load here because I wasn't running the campaign, but we can do it by just running this again. So this essentially solves the AI part of what I had planned for today. And like the stupid thing here is just the fact that it kind of runs. It disables the AI just when the road turns, so it's running off onto the grass. I need to tweak that. But then we have this camera thing, and I'm gonna blend the camera with the gameplay camera in a nice fashion. So that would be probably the next thing to look at. This boolean haunts me. I don't like it. I don't like the boolean. Yeah, I guess we'll just have to live with it for now. Let's get rid of that, and let's put a comment here that clearing the layer makes the table AI action run immediately. And I think I actually want to have a method here to clear all the layers. That's what we want to use that instead of just explicitly the primary one. Let's put that in as well. And that should be easy enough. Clear all layers. Underscore clear all layers. Just copy this basically. Something like that. Primary, secondary count. I guess we can probably iterate over that enums types. If we put our back into it. Something like, what was it? Was it meta? Enum. Field enum. Values. Values from fields. Enum set, enum multiset. How does this work? Actually haven't used any of these things. Enum indexer. Okay. Then it's zeroed. 1, 0, 2. So a count of 3. Is the indexer the easiest way to actually like get the count of these guys? Enum set const iterator, okay. Direction, okay. Up, down, left, right, okay. Right, okay, yeah. So this is probably overkill for what I'm trying to do. You can have like a set that you then insert just a few of these guys from the direction. Okay. I just want to iterate over the things. Iterator. There's an iterator over this set. And this is again the set. Okay. Okay. Oh, the map. Okay. So Google gives me something like this, where there's an std meta fields of this, right? Something like that. F is now probably, let's see, if F is count. Yeah, I have the count there. That's perhaps a little stupid. Typically don't need to do that in Zig. But yeah, this has been around for a while. So basically, like if it's not count, then we just clear it, right? Something like that. And do I actually need that for anything? Am I am I even using it? Well, now that particular piece of code, of course, won't work. Yeah, it's used here, but I bet we can just use that. What was it? std meta fields. Is then like a slice? Oh, what? Looks like a slice, yeah. I'll just get rid of that. Right. So that's actually not the way I want to do that, is it? Let's see. Field info, fields. I'm actually using this somewhere myself. I think I've actually used Right, that's a... Yeah, this is in Zig FSM. This is actually not my code. But that's probably an enum. So comp time std blah blah blah. Do I need to specify the comp time there? Comp time. Is that how you do it? Redundant comp time keyword. Yeah, I was. Oh, that's int from enum is the problem, right? Int from enum is the problem here. Enum field. Okay. Built-in type enum field. Do I need to cast it somehow? Enum from int field value. Maybe. Seems sort of unnecessarily convoluted. I bet there's probably an easier way to do it, but I just don't know how. Okay, well, maybe that is how we should do it, at least for now. I guess I can put a breakpoint there and then make sure that we actually get that called. Let's see. We have everything. So we have clear all layers here, calls that one. This guy gets a self pointer out and then calls clear all layers. And that looks good. Let's try that. And what I will do here is actually, I will export this level so that we can debug it properly. Just need to wait for the light probe rendering. Okay, exporting the level, and then we can just run it from here. Oh, you know what? I probably forgot to actually call that function from the script. I'm too eager to actually see it in action. So this guy, instead of calling clear layer, it should be clear all layers. Like that. Oh, not that. And then export again. Let's try that instead. Whoop, my audio interface is falling off the table. Okay. So we should momentarily get that breakpoint hitting. But we don't. Does that have to do with this inline 4 somehow? Let's see if we can hit it there instead. Yeah, debugging like comp time or inline force, other comp time stuff is sometimes a little weird. Oh, So still calling that one. I have a feeling that the level file just wasn't actually updated yet. So I have a background program called the asset server, which actually converts things on the fly. And even though we exported it from the level editor, yeah, now you can see now it actually works. Well, still can't quite hit that thing with the debugger. Let's try that one more time. So clear all layers. Comp time stuff can be notoriously difficult to actually debug, but we should see this go into the clear layer stuff. If we don't see that, then we'll just put some prints there to show us that it actually does work. Okay, and that looks better. Here's the given layer, yes. And layer is 0, primary, yes. And then we should get the next one, 2. But we probably just jumped over that one. Overall, like, the debugging experience is not perhaps the nicest one here, but let's do like basis print f clearing. Can we get like a string representation of that enum tag name? Name cast. Actually, we can probably just print f, right? And then maybe that doesn't need to be there. Let's see if that works. I think actually Zig prints enums quite nicely if they're sort of auto formatted. At least that builds. So we should get like cleared. Let me see. Cleared built-in type, blah blah blah. Oh Jesus. What? Yeah, that's the enum field. Okay, okay. Yeah, that's not actually what I want. It was probably this one. f.value. But I have a feeling this actually doesn't work. But we'll see. Because we only got like one output, right? We should get 2. We should get primary and secondary. Okay, no, there was 2. There was just clearing 0, clearing 1, move to action, blah blah blah. Okay. Right, so the value is there, yeah, okay. What can I get out of that? Let's see. So fields returns, in the case of an enum, it returns an enum field. It has a name. There we go. That is what I wanted. So I need to do something like that, right? Now we should get like primary and secondary. All right. I'm learning. Look at me learning about things. Yeah, there we go. Primary and secondary. Cool. And running disable AI action. Okay, so we should actually be able to, yeah, as you can see, like we can drive the vehicle. That's kind of fun, actually. We can just drive the vehicle there. While the camera is still the... Now I can do it. I can try to actually turn the thing. But if I hold the gamepad to the right now, we can see the minute we can actually start driving driving this thing around. That's cool. That is what I want, actually. The player should realize at some point that, oh, actually I am that guy, and I can drive that car. So that's very nice. Yeah. Okay, so now we want the camera blending to be added, so that we actually blend the scripted camera, that animated camera there in the beginning, with the vehicle camera, and that's gonna be a whole thing. That's gonna be a whole thing, but I will take a 5-minute break, and I'll be back in a second. Let's do something to notify new people what's going on. Maybe darkener. Probably that one, right? Isn't this beautiful? Hey Łukasz. Good morning to you. Right, I'll be back in 5 minutes or so. All right, 5 minutes up. Let's undo our beautiful 5-minute notice here. Yes, so camera blending. That's gonna be interesting. So basically what I want to do here is we have this animated camera which just follows a path, follows a spline. And it's not very well tuned, but it should do something like this basically. And around this point I want the camera to start gradually blending with the gameplay camera, so that when you actually reach the point where this car reaches basically like this place here, it should be fully blended with the normal gameplay camera. I think that should look pretty cool. So how do we make that happen? Is the question. That is the question. Shouldn't be super tricky to do. It's not necessarily trivial, but it shouldn't be super tricky to do. Let's put this AI business to rest for now, at least. And we'll go into the client player controller. And this is just like a whole mess of a thing. Essentially all the players, and this is like essentially on some level this is like multiplayer capable already. So all the clients, all the actual players, human players that are playing a game, gets one of these player controllers assigned to them. I think I determined that actually yesterday that this is not needed, so I don't know what that is. Let's get rid of that. This thing has some interesting things. There's a camera mode, which can be any of these. Disabled. Free camera with player input. Vehicle camera and animated camera. These two guys are essentially the ones that we want to blend between. We start with the animated camera. And we slowly blend to the vehicle camera, right? And we have some controllers for those as well. We have a vehicle camera controller and we have an animated camera controller. So these two are essentially sort of like calculating the position of the camera at specific places. And so, yeah, there's also a free camera controller. A free camera speed multiplier. But yeah, these are essentially the three ones that we want to sort of have them interact with one another. How much experience do you have, sir? Do you mean like in making games? I assume. I have been in the games industry for quite a while. I think I started in 2009. And I worked at 3 different game studios. And shipped a number of games. As a programmer. But now I'm doing mostly this stuff. I'm trying to get this game out. Right. Blah, blah, blah. I think each one of these camera controllers actually have their own camera. You can see here camera pointer. like if you haven't seen many of my videos, you don't know this. If you have, you know it. But I'll do a small recap here. If you see something that's like a type and then PTR, most of the time that is actually it's wrapping an object that's on the engine side in C++. So camera here is of type camera PTR. That means that it's essentially a C++ pointer. If you can have a look here, you can see that it has just a usize member and not really much else. And so if you call something on this guy, we'll actually go and call the thing on C++ side and then give you back the result in Zig form. So that's what this is, and I think all of these actually have their own camera, which is not necessarily what we want. It's kind of tricky to blend two cameras together, but what we can do is we can blend the transforms of two of these controllers together into a new transform, and then set that transform on the camera. That we can do. What's this far plane? Is it always 1600? Yeah. All of them have 1600. So I think what we want to do actually here is change this slightly. You can see all of these cameras actually come from different projects. So Means has the animated camera controller. Basis, so basically like the standard library for the engine, has the free camera controller. And then VHL, which stands for Vehicle Helper Library, actually has the vehicle camera controller. So they sit in different projects, all of them, but that's okay. I can modify all of those projects without much trouble. So vehicle camera controller is probably the most complicated one because it supports both like driving mode and then orbit mode stuff. So we just load the level. Let's not load the mission right now so we don't get that intro. So just load the level normally. You can see here, this is like the driving camera that just follows the vehicle like this. Then if you click the right thumbstick, you get this orbit camera, which allows you to look in any direction while driving in any direction. And if you click it again, it sort of blends back to that. So we're already doing a little bit of camera blending here. But that happens inside. All of this is controlled by the vehicle camera controller. If we press F1, we get free camera. We can move the free camera around. Press F1 again, we get the free camera is sitting in place. Now we can drive the vehicle. And now it blends back to this vehicle camera. So we do already have a little bit of camera blending going on. So now we just want to blend between two of these controllers. I haven't done that yet. And for that to work, I think we need to rip out those cameras from the controllers, put one camera into the client player controller, so each player again gets their own camera, just a single camera that we then feed all those values to. If that makes sense. I hope that makes sense. So let's start ripping out the camera stuff. But before we do that, let's have one quick look here. So they all have this camera and they have a camera node. Camera node is a scene node pointer in this case. And I think they all have just one scene node or camera node. Except this one has like multiple of them, but they're all then mixed together into the one. You see, post init, we create like the orbit mode nodes, and then we have just like self.camera node. That is the sort of final mixed down camera node thing. And it is also the one where we actually attach the camera. So the scene node is what you can actually move around in the scene. You can attach any number of things to it. You can also attach other scene nodes to it. And that's how we get like a scene graph. So we want to move this camera node along with this camera out of the camera controllers. Dinit just destroys that stuff. And here's the important part. So update. Yeah, here we can see blending actually. Fully blended to normal, non-hauling mode. We don't actually have hauling here yet, but I'm planning to add that. So you can have connect trailers and things. If you're hauling, then the orbit camera moves out slightly to give you a better view of what is actually happening. So there's a normal mode, and then we have hauling mode, and then we blend between those two. All right. And yeah, we're blending a whole bunch of things actually here. Yeah, I think actually it doesn't only affect the orbit camera. It probably affects the driving camera as well. Let's have a quick look here. Slide actually has it, so if we just run it from here, this is the previous project for those of you who don't know. This one has hauling. Let's see. Plane and cars. I think this probably has some things that we can use to haul. Right, let's get one of these vehicles. These can haul things. And if we move up to one of these trailers, get the connection visualization, and then we can actually connect the vehicle like this. And you can see that like the camera moves a bit forward and backward as we are actually toggling the hauling on and off. And I think that also happens with I might just have like the parameters might not be set up correctly for this one. Oh well, I guess it doesn't really matter. Oh yeah, this is hauling. You can pull things, and of course you can have dynamic objects there in the back of that trailer if you want to just pull it. But the important thing to see here is that it all comes down to a position, an orientation, and a field of view. And then we set that on the camera. We set the position or orientation on the camera node. We set the field of view on the camera itself. So this is essentially everything that we want to do for the camera every frame. That's the vehicle camera. Then we have the animated camera. It does something slightly different because it actually tracks, it has like an animation player, which is right there. So in the animation player, we update. This is in tick, so this is fixed updates. Then it pushes those to an interpolator. And then in update, this is variable rate. We get the transforms out. They're interpolated. And we get just a position and an orientation. Yeah. If we don't have transforms, then we just set the uninterpolated transforms. We don't adjust the field of view here, actually. The animated camera controller doesn't support animated field of views, apparently. But otherwise the logic is exactly the same. You just have camera node that you set. And I bet the free camera does something very similar. Probably also in the update, yeah. It's pretty much exactly the same, in fact. Probably copy-pasted from the free camera, the animated one. Yeah, okay. So this looks simple enough. I'm gonna move some of this stuff off to the side so that I can look at it if I need to. Free camera, animated camera, and vehicle camera off to the side, and then we have the client player controller here. This is where we're gonna actually put in these things. And this type is like this. This whole Zig file is just one big mess. There's all kinds of things. A lot of them related to cameras, but some other things here as well. So, when should we create the camera? Maybe when the game starts. So we call reset. What does reset do? Just set some variables. Then we set the camera mode to vehicle by default. Okay. Yeah, this looks like a place where we could create the camera, and then we can destroy the camera when the game ends. So let's just put in a few functions here to actually do that. We can have here a create camera. Can be just a void one. Destroy camera, same thing. And we need some members to actually hold that stuff. Far plane, this is something that we'll actually probably want. I'll put it here in the beginning as a constant. Do we have any scene nodes here? No scene nodes, okay. That's fine. Let's shorten some of these things. So camera is like basis render camera pointer. So I typically actually want to use the same name. Scene node pointer is basis math. Scene node pointer. Actually have some other math things here, so let's put it next to those. I probably need the renderer and the render scene as well. I can probably actually just copy it from one of those other ones. Like this. So you're gonna have multiple render scenes. There's a primary one, which is the one that the game sort of takes place in. But for example, in the editor, when you have these like thumbnails here that are rendered, for example, they're rendered with like a secondary, a background scene, if you will. Transform interpolator. Let's hope we don't actually need those, because the stuff that we get out of the camera controllers, it's already interpolated. So let's hope that we don't actually need to interpolate anything here in this client player controller. I hope that the only thing we need to do is blend together 2 or more transforms. Render scene. Right. render scene is there and we don't do anything with it. Right. So we need to get the renderer from somewhere, and I bet we actually pass the client somewhere. Here's the client. Cool. Now we have 3 new things to actually add to this guy. Let's add a camera, and this will be a camera pointer. Is there no null? There's an init null. Interesting. This is typically how I do those. So in Zig, you typically use optional pointers if you want to have them to be null. But remember that these are actually not... no, that's not actually how we do it. It's like this. Null. Yeah, remember that these are actually not... Can be just null. No, okay. These are not Zig pointers under the hood. These are C++ pointers. Zig doesn't actually know if these have a value or not. So I have this special syntax here for initializing these null pointers, just like you can do in C++. This would be a renderer pointer. We can initialize it as well, and then we have the render scene. And the scene pointer null. And immediately we will initialize 2 of those guys, and we will actually do it here. Let's see, game session camera animation. We can put it between these 2. So we have renderer is client get renderer, and returns a renderer pointer, and then render scene. Yeah, render scene is actually, I'll probably want to get that into a member here. Client get renderer, and then we just use that, because then I'll need to use the renderer to get the render scene. Get primary scene, the one that we'll want to use. And those are always, they're pretty much guaranteed to be there. So that should be good. Okay, and then we can go here to the message handling. These are like engine messages. These are defined in C++. So this comes from some like C import generated thingy. When game starts, we want to create the camera. So let's call create camera. And here we can do self.destroy camera. And then we actually... Alright, we need that camera node. C node there as well. So camera node, C node pointer, null. Like so. And then let's see how do we create the camera. Yeah, we need a default field of view. It's a vertical field of view. Let's put in a camera. So how should I do this? let's just do it like this for now. So field of view Y, that's a float 32. We can initialize it to probably like basis math pi, I think. What do I use here currently? Something like that is what I have in the free camera, at least. Yeah. Yeah, that's pi, all right. So then we have aspect ratio. And that's actually, that's something that we need to actually figure out. But we can do it here actually. Get a sensible default value for that as well. Probably go above the renderer. So camera aspect ratio would be renderer get aspect ratio. And that can change, so we need to actually, if someone resizes the window, that will actually change. Yep. And we have camera near clip and camera far clip, and those are essentially all the values that we need. I think I have this to 0.1. Far clip. We initialize that to the far plane, which is currently 1600 world units. That should be all right. Yeah. Okay. Looks good. Now then, actually creating the camera. The camera is actually created in the post init function. Right here is actually where we create the camera currently. And then we destroy it in dinit. So maybe this is actually where we should be creating those cameras in the future. Like these three functions currently create the camera. Post init is currently, it's typically called when the renderer is set up. Yeah, let's do that here. So we actually remove it from here and from here. Just set the camera mode accordingly there, but we actually create them before that. That's probably good. And then creating a camera is relatively simple. We call self camera equals self render scene create camera. And we need to initialize the camera. So set perspective. Why don't I get any help with this? Hello CLS. What's up with my CLS? It doesn't really say anything. Sometimes CLS is just like, nah, I'm not gonna show you anything. You're silly. And like this shows me all kinds of things for the render scene and renderer as well. For camera, it's like no. Well, I happen to know that it's set perspective. There we go, set perspective. And the first one is the camera FOV. Then we have self camera aspect ratio, and then there is the near clip, and then there's the far clip. Initialize the parameters like so. Then we need to create the camera node. Camera node is self render scene. I want to just connect it to the root scene node. So we essentially kind of place it in world space. If we set the position of this camera node to something, then that position is in world space. Yeah, we don't need to set any position. It's automatically created at the origin. And then we take the camera node and we attach the camera to it. Like so. Let's make sure all of this builds first of all. It does not. Oh, that's probably why. Yeah, that's probably why we don't get any IntelliSense, right? Now if I do self.camera dot, yeah, now I get all of this stuff. Expected camera mode found. What? Oh, camera mode. It's almost camera node. Thusly. And destroying the camera is basically equally simple. Take camera node and we detach the camera. We detach specifically the camera. There shouldn't be anything else there, but let's do it specifically anyway. And then self render scene, destroy scene node, camera node, not mode, but node. And we can just set this back to like scene node pointer null to be very explicit about that. And then I'm going to destroy the camera itself. And we set the camera also to be null. Camera pointer null. Something like that. Oh. That's what we want to do. All right. So that now builds. This should not really matter at all. We're creating the cameras, but we don't actually use them for anything. So everything looks just the same. Now though, if we have these camera controllers, you actually need to push the camera controller to the render queue. So it's done here in the enable and disable function. So it adds the camera to the back of the queue and the controller is enabled and removed when it's disabled. This is sort of stupid in the sense that we could just use the one and the same camera all through the game and just mix it together. So let's do that instead. I'm gonna remove these guys. Not really do anything else currently. well, now we could actually, I guess, just comment out these cameras completely. So maybe we'll do that actually. Camera and I guess camera node can also be just removed from these guys. Attach camera. Like that. Detach camera. And we don't have a camera node. We do have an input node. I don't exactly remember what the input node was for, but it's clearly used to do something. Right, if we don't have any transforms in the interpolator, we actually set the position from the input node instead. Okay. Cool. Cool. Yep. Alright, but the camera node is no longer there. So we don't want to do this. This is essentially like the output of this whole thing here, right? What these camera controllers do is that they move the camera around. And this is how they do it. So instead of doing that, we need to make this update function, which should probably be called something else. But we should make it return the results instead. Or maybe we don't actually do that. Maybe we do. Let's just do it all in one go, so we have like a working version here. So we have a camera position, which is a vector 3, and we can initialize it to vector 3 0. We have a camera rotation, which is a quaternion, and we set it to identity. And these guys can now then obviously just be red because they're fields. So we just set these. Camera position is pos. Camera rotation, or should we call it orientation? I think orientation is the orientation is the term that I've used. And instead of setting them to the camera node, we just set them to these members instead. Like so. And then those members can just be read by the client player controller. That should work. Let's see if this actually builds now. No field camera. Yeah, I can't initialize something that's not there. Makes sense. There's some more stuff here that I actually forgot to take out. Right, so here's an interesting thing, and this is something that all of the controllers have. They have this on aspect ratio changed, which calls this set perspective function that we looked at earlier. These can all just be removed. We don't need them anymore. But here in the client player controller, where we actually see this stuff, this is where we now want to update this camera aspect ratio. Like so. And now I need to remove this one call. I can just remove them all in one go. Yeah, they used to be called camera directors until I changed them to camera controllers. I can take that thing away. It's kind of silly. this is not very nice with the S things there. Let's instead do an F32, and then do like a float from int, right? And now we should just be able to do width divided by height. That's nicer. I think. So we just store the thing here in the in the member. What we could do is, maybe what we should do, in fact, is that we should just do the camera, update the camera here, set perspective, and we essentially use the same parameters that we had previously. We do the same thing here. Call this again. So take that away. So we update the camera aspect ratio here, and then we just set it like directly. I think that's probably what we want to do here, actually. However, only if we actually have a camera. So if this is not null, then we want to do it. This calls down into C++ and calculates some like frustum sizes and matrices and all kinds of things. Right. Does this build now? Looks good. Yes, that built. So now we have essentially like neutered our free camera controller completely. Doesn't create any camera anymore. It also probably doesn't need. Yeah, it actually does. This one is strange because it uses like an input node. What is it actually doing with this? So the input node is created. It's created on the root scene node, so in world space. Destroy scene node, set position, translate. Okay. Yeah, it's just doing a translation. Doesn't really need to be managed by the render scene though, I think. And that is what I think. Now I also don't think we need this get camera transform, which previously has like returned a position and a quaternion like through pointers like this. Now we just have these members here that we can read from. Yeah, okay. So let's change this a little bit. Let's hope I don't actually break this now completely. It is possible. So scene node pointer. We just want to create a new one. You can call init new. And that will create like a completely new scene node on the C++ side. It's like literally calling like the new operator in C++. And that of course means that we need to destroy it later on. But we don't need the render scene to do that. So we just call self input node dinit. And dinit knows here that like if it owns the memory, then it actually calls down into the C++ side and deletes the node for us. So that should be good. And that means that we no longer need the render scene at all. We can take these guys away. And those things can go away. And this actually just becomes very, very simple. And like I said, we don't need the get camera transform one either. Let's comment that out. Get camera transform, free camera controllers. Right, so this is this is where we want to actually set those instead. So we do free camera position would be self, free camera controller, camera position. Free camera orientation is self, free camera controller, camera orientation. Like that. Maybe we don't even need these temporary variables, but whatever, let's leave them for now. Changing quite a few things here. Don't want to break everything in one go. Let's do a quick verification that this actually builds, and then we can remove those commented out things. Yeah, we almost don't need any post in it anymore. Ah, that doesn't hurt to have it there. And no adding of cameras. No removing of cameras. It's so silly. Just have a function that says a boolean. And this can be simplified further, but let's not do everything in one go, as I said. Like so. Okay. So now we're just updating the pitch yaw movement. You can set the transform, which actually probably means that we should set them on the input node like this, but we can always do this while we're at it, so that if someone someone actually queries them right after, then they are up to date. And I think I use a scene node here just because then I can do like pitch and yaw, and the scene node figures out its position and orientation and all of that. Maybe not necessarily, maybe not necessary anymore, but it doesn't hurt. Let's do a little bit of cleanup while we're at it here. Enabled false. And these just go away. This is just kind of nice. And that can be initialized there as well. You can clearly see that I've written this quite a long time ago, because there's a little bit of stupidity in this code. Yeah, the client is the only one that we can't actually initialize up front, because it is passed here. Do we need the client though? No, that we don't. Yeah, we need the client actually, because we need the client to do the interpolation factor. Yeah. So when you have a part of your game update in fixed step and a part of it in variable step, you need to do interpolation or you're going to get a lot of jitter. And the interpolation factor is sort of like how far to interpolate between the current and the previous frame and all of that. All of that good stuff. Right. Let's see, actually I need to see one thing here on my other machine. Right. One second. All right. Cool. I don't think we can simplify this free camera controller any further right now. So let's keep it as it is. Can we build? Okay, we can build. That's cool. I think the last missing piece from the free camera one is let's move the camera stuff out of the controllers first and make them work like they used to before we start adding the blending there. So basically what we want to do now in the update method, update here, currently we just call update, and this previously would have, or specifically this line previously would have actually updated the camera node, and the camera would have been automatically updated. We don't do that currently, or we don't do that anymore. So what we need to do here is probably something like this, where we have like camera pos, and this would be a vector tree. We can again, actually we can probably just don't need to do that if we initialize it here. Camera ori is quaternion identity. And what we need to do here now, this is the important part, is like here we can essentially do like to do blend multiple cameras together if we want to do that. But let's do an early out if we don't have a camera for some reason. Actually, that should never be the case. Let's assert that we have a camera instead. Assert that self.camera is not null, since we now do it there in the post init. It should always have a camera. Should always have a camera node. Set position would be camera pos. Camera pos. Self camera node. Set orientation would be camera ori. Like this. Some of these things, some of these controllers can also update the FOV. So let's do, this can actually be a const. Let's do old FOV F32, and this is like self. Actually, no. Let's not do it like that. Let's just do it FOV, and it's a variable, and it's self camera FOV. So then we can here in the vehicle controller, for example, we can do like FOV equals, you know, FOV something something. Let's just set it to 0 here so that I can keep that as a variable, otherwise it will be disappointed with me. And then if basis math floats almost equal, so like not float almost equal. Terve terve. Tere tulemast. That's actually not Finnish, that's Estonian, but terve nonetheless. So if the FOV has been changed, if it's not the camera FOV that we were used to, then we need to do that set perspective thing again, which is not actually free. But the driving camera in particular just changes the FOV all the time, depending on the speed and all sorts of things. This will obviously break. Maybe we should put that to something more suitable. What's the basic math? Pi times 0.25. But yeah, the vehicle camera controller will update it continuously, so this will run, but still we don't want to run it unless we have to. In orbit mode, we actually don't change it all that often. So that can just be FOV, or we can do the same thing. We can do camera FOV. I can actually just copy that same thing. This is the thing we want to do. Yeah, so this is now the update for the camera, regardless of which camera we're actually using. That should work. So with a little bit of luck, we should now actually be able to use the free camera. Camera pos is self free camera controller, camera position. Yeah, the actually this probably won't work now because I'm working on the camera. You'll see in a bit. I did fix the brain thing. Actually, I fixed basically all of the hacks and weird things that we've had to do in the streams over the past few days. There were some data streaming issues with. If you remember, I had to put in that weird manual timer to bring in objects in a certain order. All of that stuff is now fixed, so we have the more simple scripts, more robust scripts now there. So yeah, the AI thing was actually the reason that happened was that we ordered the Scout to drive to the junction, right? And when it arrived there, it was like, right, I am at my destination. I'm just gonna basically stand on the brake now. So that's why, no matter how much you tried to drive the vehicle, the AI was like essentially holding onto the handbrake and not letting you do anything. So I just added a system where you can. It's a little. I'm a little disappointed with the API still. I probably need to do something about it. But now that you actually move somewhere here, move to object, there's this deactivate driving AI post movement. You set this to true, and that means that when the movement is complete, it just like completely relinquishes the control from the AI, essentially giving it back to the player. And it works pretty well, except now I'm knee deep in the camera refactoring to have that camera blending going. But yeah, it works pretty well. Hopefully we should see it in a few moments when I have this camera business wrapped. Where was I? Yeah, I was here. So we need to do this for essentially like, we need to update the controller in question. We need to do this to get the stuff out of the controller. And then we set it on this node. And obviously if you want to blend two different controllers, this logic won't work exactly how it's currently doing, because we need to update. Like specifically here, we want to blend from the animated camera controller to the vehicle camera controller. And so naturally we need to update both of those while that is going on, and then mix those transforms together into these two. And yeah, all kinds of things. It'll be interesting to see. Now that I look at this though, I wonder if all of the controllers should report their FOV as well. Because we need to probably mix together the FOV as well as we are blending them. So maybe we'll do that. Maybe we'll have a camera FOV F32, and that can just be the standard one that we have. And so it's essentially like this. Now let's make all of the controllers have this as well, and then they can change it if they want to, and or leave it if they don't. And that means that I can now set the FOV here as well. Self free camera controller FOV. I can just be FOV. Right. I hope that makes sense. Otherwise, when we try to blend the driving camera and the animated camera, the minute the frame we actually start the blending, the FOV will most likely jump to whatever the vehicle camera controller wants, which is typically a lot larger than the animated camera. And we don't want that. We want the FOV to smoothly blend as well. All right. Okay, so this now builds. Did we actually... what are those other controllers? Vehicle camera controller. Yeah, I removed these add camera, remove camera from all of this. So if we now actually play the game, the camera should be broken, but with some luck, the free camera is actually moving. So you can see like, okay, that's not good. Yeah, it's clearly not working. We can drive the vehicle still. That's nice. Let's see. There's the free camera. Free camera. Free camera. Free camera. Free camera. Okay, that's not good. Let's start that slightly differently. Because we have that I have that animated camera doing crazy business there. And so that's not good. Okay. I wonder why we're not seeing anything. Free camera controller. Oh. I mean, we still need to add the one and only camera there, right? Add camera to back of queue. I don't think I'm doing that. Renderer. Add camera to back of queue. Yeah. Like so. And here we just remove it. Much simpler than what I had previously. Yeah. Yeah, vignette is actually surprisingly effective. I've had that vignette effect there for a long time, and it's not something that you typically really notice. But then if you take it away, it's a bit more boring. Right, so here we can see things again. This is the vehicle camera. You can see that if I drive, you can see the gauge there reacting. If we put on free camera, you can again see things. This free camera is a little crappy, to be honest. It probably doesn't show on the video, but the input is actually ticked in fixed. Oh, now it sets it back to the vehicle camera again. The input is ticked in like the fixed step, so there's a little bit of lag here. I should change that to be the same as like the camera in the editor is really smooth. It's all really, you can only really feel it if you're playing with the mouse and keyboard. Well, yeah, this is free camera. If we turn on free camera with player input, we can drive, but can't see anything because we're now sitting at the world origin basically with the camera. Vehicle camera. Yeah, it just jumps back there when that happens. Okay. Okay. The animated camera controller could be the next thing on our block. Should be relatively simple to do. Let's move the free camera here to the right. And actually we can probably just remove most of this stuff as well, right? Well, not most of it, but we can remove those. And we can remove them from here as well. We don't need the render scene, we don't need a renderer, we don't need the camera. Probably don't even need the camera node. Yeah. Yeah, we don't need any of this crap. It's gonna be so much simpler, it's very nice. We don't need the far plane, no, we can remove that. It's quite frankly just been a large amount of duplication in these camera controllers, and they're now just moved to the scene, the client player controller instead. That's nice. We do need these three though: enabled, animation player, and transform interpolator. Yeah, so these I'll let these handle the transform interpolation. That's nice. Enable can be set to false here. And we can just comment out a bunch of these things. Again, camera node enabled is set already. These two guys go away. You don't really need any post in it at all. We don't create a camera, we don't handle the aspect ratio, we don't do any of this. Just remove that completely. D init is the same thing actually. enable, disable, yeah. They can probably stay as they are. We're dealing mostly with the animation player there. Right, so tick updates the animation player and gets an uninterpolated transform, pushes it to the interpolator. Update needs to be changed according to this new standard that we have going. Right. Position and orientation. We don't have that. That can be taken away. We don't have that. Yeah, that's probably a good thing to have there. I think we need all of that, all of the stuff that's left there. And now we just need to basically do the same thing here for the animated camera controller. Let's see, we don't have the post init and D init at all. Do we have the D init? Do we actually? Animation. Yeah, the animation player has an init, but it doesn't really have a D init. Animation player. Okay, that's fine. Then we'll keep it as it is. Right, next thing, tick. Tick can stay as it is. And yeah, if the animation has finished, then we set it back to whatever it was before the animation started. And here is again this thing here. Animated controller. We don't have the get camera transform. Instead we do it like this. And I think this is probably fine. Yeah, that should be fine. See if this builds. Do we actually have working animated cameras again? Hey, we do. Very nice. Not exactly sure how I will handle the controlling of the. You can see that I can actually drive this thing here while the. Let's load the game again. I can hold like the steering to the right, for example, like this, and so far the AI is controlling the car. At some point, it will relinquish the control of the AI, and you can see that the car starts driving off to the right like this, and now I can just drive this vehicle normally. And this is, of course, when the camera blending would take place. And now when it goes to the vehicle camera, it just breaks because the vehicle camera hasn't been ported yet. So that's good. Yes. But yeah, I'm not sure exactly how I want to like control this blending. That's a bit of a question mark still. Here is where we set the final transform for the camera, and we can do anything here before that. But I need some sort of API to make that happen. Start blend between this or that. So, not sure. But we'll figure it out. Okay, so now we have the most complicated one left. The vehicle camera controller. This one is a pretty big one, 750 lines. And it's mostly because this one just does a bunch of things internally. So yeah, this has like driving mode data, and it has 2 of them actually. And that is because of the hauling thing that we talked about earlier with hauling. If you're hauling like a trailer, then the parameters can be a little different. But it should be fine. Blended camera component is probably not exactly what we want here, because we're operating on a lower level than the game object model currently. So the way this works is that this is the means client player controller. If you have a look at where that is used, it's here in the means app. There's a callback that you need to provide. This is actually not super Zig idiomatic, but it's just because this is how the engine works. The engine needs a client player controller whenever a client joins. So if you have a multiplayer game, each player gets their own client player controller. See that it's just like an int pointer, because we need to give this to the C++ side. And this guy is created actually when the game is creating, the game session is created, which in terms of like a single player game is like in the main menu. We also have a server player controller, which I think it means doesn't really do anything. Alright, it actually handles some interactions that need to be triggered from the server. Yeah, this is it's not even 50 lines on the server. Oh yeah, every player gets one of these guys as well, and this obviously runs on the server, while the client player controller runs on the client. Like we're way before actually creating any sort of game object at this level. So we don't have components, if you're thinking about them as like game object components. We don't have any game objects yet at this point. Typically how I've done this in the past is that I have a script function which I call. So for example, let's see, there's the mission elevator intro timeline. So this has like an add camera and animation event. You give it the data block, which is like the whatever animation you want it to play, and then you add one of these camera animation events. This will actually camera animation, it's called a timeline camera animation event, like this. What this will do is it will actually send a message. So play camera animation from level data block, and this guy is then actually reacted to, you can see here in the client player controller. And then you can pass parameters. So we just get the data block name here. So I might want to do something similar, add a new game logic message here. The nice thing about that is that it will work essentially from anywhere. You can just tell the system that like, hey, right now start blending between the camera animation and the vehicle. Sorry, the camera animation, animated camera and the vehicle camera, and do that over say 10 seconds or something like that. And I think I will probably wrap it in the same kind of event like this, because then you can time it with a scripted timeline. Something like that. I don't know. HRN asks, hey, how's your experience with Zig so far? It's pretty good. It's pretty good. It's getting better all the time. It used to be kind of a crapshoot in the beginning. I shouldn't maybe say beginning. I've used Zig since 2019, so that was like version 0.5, I think. At that point, the debugging experience was really quite horrible, and the language server was also really quite bad. But it's getting better all the time. The debugging is still probably my biggest pain point, to be honest. Right? We did some debugging earlier today in the stream, and it's a little confusing sometimes. I'm running this Zig library now in debug mode for the game. So I guess it should have been pretty debuggable technically, but yeah, there's some confusion still going on with that. What else? There's some things that I would like it to have, but I guess I will never get. Things like operator overloading and things like that would be pretty nice for game development. But yeah, overall it's really nice. Obviously that's why I'm using it, and plan to continue using it, at least for this game. So it's not bad. Oh, actually, yeah, there's another pain point. The release build compilation time is a little long, like annoyingly long. But of course they're working on that right now, and they're even talking about adding hot updating, hot library loading, whatever you want to call it, to the language. And so that should just be super, super nice if that lands. But yeah, that's kind of a pain point, to be honest. I'd like the compilation speed to be faster, and I think a large part of that is actually LLVM, which is not really Zig's fault, but still it's faster than building my engine, which is still in C++. So, but yeah, it can be a bit tricky to compare. Right, the camera. Let's get cracking on the camera. So I think this one actually probably creates a bunch of C nodes internally. So orbit mode data has like a vehicle node, a vertical tilt node, and a camera node. And then it has the main camera node. This is the one that we want to get away from. We want to remove. We don't want to have. But those other ones we can still leave there. I don't think we'll need to have them in the render scene, though. Just like this. Let's see. So what are we actually doing here? Post init, d-init. So here what we're doing is twice, and this is the old style for loop. We can replace it with the new style for loop instead. All right, something like that. Oh, it's not a for loop. It was a while loop, but yeah, previously you couldn't do this kind of for loop, which was annoying. Now you can. So what we're doing here is we're initializing the 2-orbit mode objects. We create a vehicle node which is nested under the scene node's root node, so essentially in world space. And then the vertical tilt node is actually nested under the vehicle node that we just created. And then the camera node is nested under the vertical tilt node. So if we do the same thing we did previously, where we don't actually create this in the render scene, because there's really no point in doing that. We're just polluting the render scene with nodes. We can quite simply initialize it as a new freestanding node. I think that should work. Let's see, where do we actually use the vehicle node? Initialize it there, we de-initialize it there. Set position in space. It's set in the parent space, but the parent space is like world space. So what? Then we set the orientation. Yeah, that's it basically. Okay. I think we should be able to just rip this out of the render scene completely. But let's do that last. There's no point in if that doesn't work, then it'll be more obvious if we first make this work with the new system and then we break that at the end. We don't need a camera pointer though. That one is for certain. We can take the camera out. We can take probably the aspect ratio out as well. We don't need to have any of these guys. Aspect ratio as well, just remove that. Camera node, detach camera, all of that can just be removed, and all of this can be removed as well. All the places where this aspect ratio stuff is should be removed. This is update, this is exactly what we want. So POS and ORI and FOV. Yeah. Yep. So here we just want to write to those members that we added to the other ones. So we need to add those members here as well. It's these guys. Update. And instead of doing this, we just do this. Self.camera FOV equals to FOV. Right. Aspect ratio changed is no longer needed, and get camera transform, again we should not have that. It's here instead, like this, and then vehicle camera controller, we can take those guys out. This probably doesn't build now because I removed so much from that vehicle thingy. Does it actually? I'm always surprised when I do something right. Okay, let's just YOLO this and see if it actually works. I should probably have just loaded the level. Could have gone straight to the vehicle camera. Alright, so it still doesn't work. Still sitting here in the center, but I think that's probably because I forgot to write those values here in the update method here. Yeah, that is exactly what I did. And if it is disabled, then we do that as well. Okay. I think we can do something like this, right? Something like that, and then we can take that away. Maybe this should be first. And disabled is kind of like the initial state. Yeah, let's just load the level and see what happens. There we go. I should really rename this level to something other. Hey, look at that. Vehicle camera is working. Yeah, and all the blending between the different modes, like orbit mode and everything, works as we want, but that's hardly surprising because we didn't really change any of that. But yeah. Okay, I probably need to have a little bit of a think about how I want this blending to work, but let's just like hack something in quickly to see if it actually sort of does what we expect. What I will do first, though, is that thing that I mentioned previously, where we actually just let's see. So we create a child node. I wonder about the destruction of these like nested nodes. If you create them under the render scene, you can create them like or destroy them like this: render scene, destroy scene node. You can't do that if you don't create them under the render scene, obviously. We can look at the C++ side here and have a look like scene node. Detach all, destroy all child nodes. Right. This calls delete on the thing, and then the destructor will destroy all of its child nodes, etc., etc. Yeah. Right, sorry, I have to take care of a small issue. I'll be right back. All right, situation resolved. We're back. So basically, I should be able to just destroy that root scene node. It should handle all of its children. Destroy all child nodes. I wonder if we actually exposed that to Zig, just out of curiosity. Yeah, destroy all child nodes is here. So we can even do it explicitly if we want to, but I don't think there's really any reason to do that. But my point is basically this: we can get rid of the renderer and the render scene. We really don't need those anymore. Yeah, we're even using physics scene here because yeah, we're sweeping for camera collisions with this camera. It's quite a complicated thing actually, but that's fine. So basically we do, instead of this, we do scene node pointer init new. Right? Like that. And these can just be null. Null is the same as init null, but it's just shorter. And here we don't destroy that. Instead, what we do is, if we want to be very explicit about the thing, we call vehicle node destroy all child nodes, and then we call dinit, and then we set them to null. So now we're not actually touching the render scene here at all, which is nice. Don't pollute that with stuff that we're not going to render anyway. And again, let's see if this works, if this builds. Yeah, same thing here. Render and render scene. Just go away. Yeah, that works. So let's try to run this. I'm gonna just load the game. Make sure that all of these cameras still work. Yeah, there's a little bit of jittering here for some reason. Yep, that looks good. Again, I have a feeling it's probably something to do with the recording. Now it doesn't jitter anymore. All right, good. Yeah, so that now works. Cool. Let's do a quick cleanup pass on that, and then let's get to the fun part. We can try some basic blending on those cameras. Yeah, take these away, those away. And really what we can do here is like just the same thing we did previously, where we're just moving a bunch of these things over to be initialized there in place. Yep. Right, camera mode blend factor. So we're blending between the driving mode and the orbit mode too. And then there's another blending factor, which is the hauling blend factor. So there's a whole bunch of blending already going on here. Driving camera enabled. What is that? Okay. It's just internal bookkeeping, essentially. Using gamepad, we need to do that as well. What are we using that for then? There's some basic aim acceleration going on if you're using gamepad. Yeah, okay. Yeah. Okay. And it's just asking the input system if we are using gamepad. Okay, cool. Right. Alright, so taking those away. Most of the stuff will fortunately stay as it is. We can remove those. There are some internal things. I don't think any of this changes. No. Okay, cool. So now the great camera refactoring of 04 should be done. just removing a few of these things we already commented out from the animated camera controller. And we'll do one more test on the game side to make sure that all of the cameras work. Yeah, might seem like a pretty big thing to do just to have an introduction sort of look and feel a certain way, but I think this is actually kind of important for the whole sort of narrative side to make sense. Also, we're fixing a bunch of weird things in the tech overall with this, so it's turned out to be a pretty good exercise. Yeah, like here you can see when I toggle between the two modes, we do this like movement between the cameras. We don't just snap between them. So, how do you blend two cameras together? The positions we can essentially just lerp, linearly interpolate, and the rotations we need to slurp or spherically interpolate. Spherical linear interpolation, I think, is the term. Let's see. Let's have one more look at the vehicle one, where we actually do it. Okay, I'm actually smooth stepping the position. But yeah, the idea is the same. So we have a factor which goes from 0 to 1, where 0 is like completely in one mode, in one camera mode, and 1 is completely in the other camera mode. And then you just increase that factor, and it handles the rest. Right, so what is now the simplest way to get this stuff blending? What is the simplest way to get this stuff blending between those two guys? So first of all, what we could do here is animated camera, blah, 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 blah. Let's go to client player controller to update. And if we are in the animated camera, then what we can do is we can also update. Let's add like a hack section here. Hack section begins here and ends later, just so that I know what not to actually submit. And what we do here is we also update the vehicle camera controller. And then we get like vehicle boss. And we get vehicle orientation. And we get vehicle FOV. Camera FOV. And the animated camera controller has a time. It has an animation player, first of all. If we go in here, animation player, right. The animation player has current time. Let's have a look at our timeline. again. So if we go to intro timeline, camera animation time, we started at 0. At 20 seconds. At 20 seconds, we start. We set the avatar. So at 20 seconds, when the animation has reached time 20, at that point the avatar is set, and there is essentially sort of some point in updating that vehicle camera controller, because it has something to actually like focus on and all of that. So if you give it like half a second or something, to just like a little bit of margin there, so like at 20.5, if you start blending between the current animation camera controller managed transform and the vehicle transform, and then we blend over like, I don't know, 5 seconds. That should be pretty easy to do, and that should give us a nice, somewhat smooth blend there towards the end. So let's see, let's get like const t, that would stand for time. So animated camera controller, animation player, current time, and then we have the factor, the blend factor. And we do a remap float time from 20.5 to, shall we say, 25.5, so that would be 5 seconds. We have 0 to 1, and we don't have any Fs in Zig. Right, so now we get the factor to blend between those two. And now we can quite simply do camera pos equals basis math smooth step, or is it actually probably like vector 3 smooth step. The factor is that the original one is actually camera pos, because that's the thing that we read out from here, from the animated character one, and then we have v pos. That's the other one. Camera orientation would be basis math quaternion slurp, and same thing. So camera ori and v ori, and then FOV is just basis math smooth step flob, what? No, fob. Fob goes from fob to vehicle fob. Right? So very crudely hacked into this, and we can print the, if there's something to debug here, we can do t is 2 decimal places, and the factor itself would also be 2 decimal places. T and F. Right? What do you think? Will this work? I guess it might. Just might work. Let's see what we have. You should immediately start seeing, yes, time is running, and the factor is 0. And so the camera should essentially sort of catch up to the vehicle. All right. Yeah, it does that, but it goes to the it goes to the world origin, and that would be because apparently apparently I misread the what's it called, avatar setting thingy. But I do wonder if we can't actually just set the avatar earlier. Might be able to do that. So set avatar is sent to this guy. Yeah. So let's split this off into two things. Let's call it disable AI. And disable AI runs these clear all layers and appends that disable AI action. Set avatar just sets the avatar, unsurprisingly. So intro timeline set scout avatar is that. Clear scout AI. Like that. And avatar set time is 20. Actually, yeah. Is that actually the problem? It might not be the problem, because I'm looking at this and I'm like, Like the mission start time is at 20, and the avatar set time is also at 20, right? So let's see. I actually think that, yeah, it is set there, but for some reason it doesn't, like the animated camera is sort of overriding that thing. So we are updating the vehicle camera. Oh, I know what this is. I know what this is. We need to tick it as well. It's not enough to just update it. We need to tick it as well. Free camera. Where's the vehicle camera controller tick? Right, it's here. And here we have camera mode is that, so we only tick it if that is. Let's hack that as well. Oh, and of course I need to build it, which means that I need to shut this down. Just shut the whole thing down. There we go. Yeah, I kind of just want to make sure that this works, and then I can come up with a better and nicer API for doing these blends. Might require some thinking how I want to do that, actually. So now let's see. Alright, it's still going to the origin, unfortunately. I wonder if that message is quite simply not getting sent. Like here we can see that it's hitting that breakpoint there. But what if we reload this again? And we set the breakpoint there now. It is okay. Local avatar transform updated. Yeah, this is the avatar. Yeah. Local avatar transform updated. Let's do this. Let's have like a basis debug draw sphere at the position. Let's give it a big enough radius, so like point, I don't know, 0.6. Color can be just white. So this is in tick. It's actually not in tick, but this message is sent from another component's tick function, as this comment here specifies. So this is essentially tick, which means that this draw sphere might flicker a little bit because it's not actually rendered necessarily every frame, but it should be rendered almost every frame. Now let's see, because now it should tell us like the position of the avatar. That guy is not yet the avatar, so there's nothing around it. Yeah, so that guy is the avatar. And now that guy is the avatar, right? So why is it going to the origin of the whole world then? So here we're just calling update. We don't only pass in the delta time. We don't pass any other values to it. So it gets everything from this. Let's see. We initialize it. We call post init, dinit, and then this is the place where we actually get that stuff out. Yep. That is good. Yeah. I just want to search for that. I think this enabling thing might be the reason. Yeah, that is probably the reason why this happens. So if we set the animated camera, we enable that. We'll just slap one of these guys there as well. I'm gonna have to undo all of these hacks pretty soon. I'm gonna forget what is actually a hack and what is not. I think it's the fact that it was updated, but it wasn't internally enabled. Which is not like arguable if we actually need that internal enabled flag at all. All right. Fingers crossed. No. Jesus. Okay, tick. Where's this actually used? Yeah, so enabled that would have not actually worked. It would have moved it to the origin just by having this thing here, skipping the whole blending if it was not enabled. So that's a thing. All right, what's the position? Yep, that actually looks pretty good. All right, now it works. Okay. Weird. Did I just not build that? Is that the problem? I just didn't build it. So now it works. I'm kind of used to Visual Studio. Just if you make a change and then just hit F5, it just builds it. But at least with my current Visual Studio Code setup, that's not the case. It doesn't work like that. You have to build it yourself. So hey, look at this. The camera is sort of wobbling a little bit when you actually move it, but that's pretty cool. And then we get some, yeah, okay, we get an assert here because now we're trying to quote unquote enable the vehicle camera, and it's already enabled. And the thing is just like, what? What? Well, hey, it works. It works as I wanted it to work. And we can just actually ignore that assert failure for now. Yeah, I need to come up with well, first of all, I need to fix this weird camera path here, which just glitches through this vehicle. But like you can already start driving here, and like the camera kind of follows it all the way, and now we'll get that assert, I'm sure. Yes, and I will just ignore it. I don't care. So it's sort of a cutscene that you can sort of start playing before the cutscene even ends. It's kind of nice. You can ever so slightly affect how the cutscene will end. Actually, you can probably affect it quite a lot. Let's see if I just make like a U-turn. What will happen with that camera? It might just go completely bananas. Right, so holding controller to the right. Yeah, it's just like, whoa. Yeah. But hey, it's working. I think especially if we disable the AI at a slightly better place in the cutscene, because now it's disabled when it's like running off the side of the road there. So doesn't look super nice. I think I don't want the camera to be that far from the scout when that actually happens, so it doesn't need to like do this really big sprint at the end. That should look really nice. And here we have the... Oh no, the power is out. Oh no, what do we do? What do we do? And then we can have the mother vehicle driving here as well. And almost ramming through the doors. It's kind of imposing when it like almost runs you over. Yeah, fun times. Okay, folks, I think that's pretty much everything I wanted to do this stream. Anyone have any questions or comments or anything? If not, then I think I'm gonna go have some lunch and then start specking out the camera blending API. Let's watch that intro one more time. And actually, let's see, if we watch like the whole thing, right? There's this intro animation which I demonstrated in like a previous. I got rid of that. 1 second. Let's restart this whole thing. I'll just put the volume down. I haven't mixed it in for you anyway. Yeah, this still needs to be triggered by hand. I need to fix that. But I'm hoping this now kind of fits together with this intro slightly better than it did previously, or a lot better than it did previously. Now there's still the wrong vehicle here. There's the old test vehicle in this intro level, but if you can look past that, then it should be pretty nice. Oh, hey, we've broken the AI. Yeah, I know what the problem is here. Okay. 1 second. Yeah, we've broken the AI because we as I mentioned previously, actually we can't export this level now, this intro level. If we try to do that, we get export errors. That would be because there's no longer any object like that, and this is now called append move to object, and this is something like, what was it? What did we call it? Disable AI on movement done, or something like that. Doesn't really matter in this case, but that's kind of what it is. Intro nav target, yeah, okay. So copy that, move it here. Okay. Alright, now it should work, hopefully. Spawn point not found. The free camera setup is activated. That's fine. Previously there was an error or a warning about bytecode not being loaded. Let's see, do we have any cars driving? Driving now. We do. Nice. Oh, damn. We might actually be blending some crap here. Yeah. Yeah, we might be blending some crap here now because it's obviously it's we have this thing going on here as well. There's no what camera animation. It doesn't matter what camera animation we're blending, it's going to start doing things. Yeah, and we don't have any. We just goes on the ground. Yeah, we don't have any avatar set here, so that was stupid. But that's just the hack that we added. Okay, yeah. And then we have the guys coming in from the big plane. Yeah, the camera should be much closer to the scout here already, so you don't do this big sprint at the end. Yeah, that's some sort of intro right there. Maybe that'll work. All right. Let's end this stream now. Got pretty much done what I wanted, what I hope to get done. Thank you to everyone who joined, even though this was at a bit awkward time maybe for most people. Or not, maybe not. But at least it was morning for me. If you like this kind of stuff, then be sure to subscribe. Leave your comments in the comment section. Like the stream if you like the stream. Click the little bell icon. And all of the other things that YouTube makes you do. And if you like this stuff overall, then be sure to hang around. Every day we're getting closer to the demo release. You guys get to actually play around with this stuff. if it looks like something you might want to do. Right. Have a good one. I hope to see you in the next stream. Take care. Bye.